Hello dear students, welcome to the Quantum Guru. Let's see this question number 3.24 of Irodov. The question states electric field strength depends only on the x and y coordinates according to the law E vector is equal to A into xi cap plus yj cap. Divide by x square plus y square where A is a constant and I cap j cap are the unit vectors of the x and y axis. Find the flux of the vector E through a sphere of radius r with its center at the origin of the coordinates. So this is a sphere of radius r whose center is at the origin of the coordinates. And let's see some point on the xy plane. This is xy plane. And there is a point here on the xy plane. Its coordinates are x, comma, y, comma, 0. So the vector that you see here, this vector has a tail at the origin and the head at this point x, comma, y, comma, 0. So this vector is say r vector, its magnitude is r, and the unit vector in the direction of this r vector is r cap, and this r vector then can be written as a x I cap plus yj cap, and the magnitude of this r vector is small r is equal to obviously square root of x square plus y square square root. Now at any point electric field is given by this expression, which is a into xi cap plus yj cap divided by x square plus y square, putting in the polar coordinates. So I can write in place of xi cap plus yj cap as a vector r, and in place of this I can write r square, and we can write r vector is equal to r into r cap. This is the magnitude of r and this is the unit vector in the direction of r vector. So that can be further simplified to a r cap divided by I. So the magnitude of electric field at any point is A by R. And what's important that this R is the distance not from the origin, but this R is the distance from the Z axis. So at any point, electric field is in the radial direction, and that radial direction is not taken from the origin. That radial direction is taken from the distance, radially outward distance from the r vector, from the z axis. For example, if this is a z axis and I'm here, so this is the r and this is r cap. If I'm here, this is r and this is r cap. If I'm somewhere here, this is r and this is r cap. So I think that is clear that here this r electric field in the radial outward direction, and by meaning that radial outward direction does not mean the tail of that electric field vector as the origin, but radially outward direction with respect to the z axis. Now having noted this, now come to a general point, and let's split this sphere into many rings. Like I can take a ring at an angular position theta to theta plus d theta. Here I have taken this angular position theta from the r vector, and at this point now, and the width of this is d theta. So now at this point here, electric field would be obviously along this r cap direction, and I told you r cap is the radial away direction with respect to z axis. So here electric field is this is the electric field, and this ring is a surface point of the sphere, and area vector is perpendicular to the surface like this. And suppose this ring has a width, the ring has some width, that width is say r d theta, because the radius of this sphere is r, this angle is v theta, so this ring has a width r d theta. And if this angle is theta and that angle will also be theta, so that angle will also be theta. Now we are ready to apply the formula, and it will be straightforward. The bigger part was the geometrical part. So now first of all, see what is the magnitude of the area of that element that we have taken. So if you cut that ring, that will become a rectangle, and the length of that rectangle become 2 pi r, and the width is r d theta. At any point on this ring, area vector ds is and electric field E has an angle theta between them. So for this complete ring, the flux through this is d phi is equal to E dot ds. So we will write the magnitude of E there. That will be simply A by R. Magnitude of ds would be 2 pi r into r d theta, and cosine of angle between them, that will be cos theta. So this small r will get cancelled. So now we have d phi is equal to 2 pi a. This was actually r d theta, 2 pi a r cos theta into d theta. So the total flux through this whole sphere will be integration of this d phi, and that integration, in that integration variable is theta, and for the complete integration this theta will go from minus pi by 2 to plus pi by 2 to cover whole sphere, and that integration is a very straightforward integration. It has a value 2. So final answer will be 4 pi a r, and that is our answer.